Okay, so in this video I'm looking at a couple of problems from, this is in your textbook. This is number 27 in section 1.5. And I'm just going to go through a couple of these. Hopefully if I do a couple you can kind of get started. And you know, these things just kind of take some thought. There isn't a single method, a step-by-step method that's going to work every single time, but so our domain in these is the set of integers, and so we have to keep that in mind. And so if we look at this, I think this is part A in that problem. For all n, there exists an m so that n squared is less than m. So let's see. I mean, can you kind of make sense of this if you just pick out a couple of integers? I mean, we have this existential, right? We have this existential quantifier that means if you were to pick out some integer m, right? So I don't know, pick out some integer that you like, 9 maybe. I mean, does it even make sense that if you picked out some integer m, does it make sense that you could find another integer over here that when you square it is less than m? And you certainly can. I mean, there's quite a few you could choose. You know, 1 squared would be less than 9, 2 squared would be less than 9, 0 squared would be less than 9. So even if you try -1 squared, that works, less than 9. So I mean, that seems reasonable. It's asking if we pick an m, could we always find some n so that n squared is less than m. Okay, now we have to remember that if we're going to show this is true, we have to show that there exists some m, right? So if we're going to show that this statement is true, we would have to go in and select an m. We'd have to go in and select an m that's always going to make this true. Now, the way this one's a little bit more complicated because the way that we select our m is going to depend on what the value of n is. I mean, the way I thought about it, I picked out my m first, but if I want to make sure that that m value is greater than n squared, I mean, how can I do that? You know, if I've got 2 squared, right, then I've got to make sure that whatever is over here is greater than 2 squared. So maybe 5, right? If I'm going to select my m, if over here I've got 3 squared, I've got to make sure that whatever is over here is greater than 9, so maybe 10. Of course, it could be 11 or 12 or something like that. So maybe if I just make sure that this value is 1 greater than n squared, if that's always true, if this is how I select that m value, then I should be okay. So we could say something like this: let n be any integer, and we're going to pick specifically m to be equal to whatever n squared is plus 1. And then if I just substitute that n squared plus 1 into my inequality, then I would get a statement that is, if I subtract n squared from both sides, I get 0 less than 1, right? Which is something that's always obviously true, right? It's true no matter what the value of n is. Okay, so something like this, you know, I think there was over here, I just kind of did some tinkering and trial and error, and it may not be something that's going to come to me right off the bat. I might have to play around with things. I might have to go down some paths that are incorrect. Right? It takes probably some time to think through these things. Let me go ahead and look at part B. Now this one's going to turn out to be a little easier just because of the inequality that's given. Again, the domain is the set of all integers, so we're asking, is there an n so that n is less than m squared, no matter what m is? And this one I think is a little bit easier to think through, because if you think about some integer squared, if you have an integer squared, that's always going to be positive. That's always going to be positive. And the existential quantifier is on n. So all I've got to do is pick out some n that would always be less than a positive. Right? So since my domain is integers, I could pick any negative integer for n. So in this case, I can pick an actual specific numerical value for n. I think any negative integer would work, because if you pick n to be, say, -3, this is always true. A negative is always less than something squared, right? So in this case, you could say something like pick n to be -3, or whatever negative number you like, and then we're going to let m be any integer. Right, then -3 less than m squared. That's true no matter what integer value m is, right? So this is always true. Right, so again, this is a common, this problem is common in a textbook where you cover nested quantifiers. So I've had some experience here, which is one reason I can look at it and say this is a little easier. But again, you may do some trial and error and have to play around with things. And, you know, I don't do that when I work out the problems, because I don't want to make you watch me think. I tried to show a little bit about my thoughts up here, but I'm not going to make you watch a video where I just scratch out senseless work and I think about a problem for 10 or 15 minutes, although that may be what you have to do when you work on these. So I don't know, in this problem I think A and B are probably two of the more difficult ones. So I'll let you try the others, and hopefully this gives you a little direction and hopefully makes a little bit of sense for you.